Okay, so I'm picturing this, um, you're at a party, right? Trying to carry a tray full of drinks back to your friends, but one glass is just a little bit out of place,
Yeah, I can see it.
and the whole tray is wobbling. And you're like, oh no, this is going to be a disaster,
Yep, been there, done that.
right? You know that feeling. Well, imagine that, but instead of drinks, it's thousands of pounds of metal hurtling through the air.
Yeah, that's basically aircraft weight and balance in a nutshell, isn't it? Understanding how weight is distributed is absolutely critical in aviation.
And that's exactly what we're diving into today. We're going deep with the Weight and Balance Handbook. And look, this isn't just for pilots, okay? This is about the physics and engineering that makes flight possible, the stuff that keeps all of us safe when we fly.
This handbook really lays it out clearly. It breaks it down into three main things. First, you gotta know exactly how much the aircraft weighs.
Makes sense.
Second, you need to keep meticulous records of any changes to that weight or balance.
Okay, like if you swap out a radio or add some new seats.
Exactly. And third, you have to make sure the aircraft is loaded correctly before every single flight. Because every flight is unique, right?
Yeah.
Different passengers, different cargo.
Right, right. Now, this might seem obvious, but why is getting this weight and balance thing right so crucial? It's got to be more than just making sure the plane can get off the ground, right?
Yeah, way more than that. We're talking about the aircraft's ability to climb, to turn, how long it takes to take off and land, even how much fuel it burns. In some cases, an incorrectly loaded aircraft might not even be able to take off safely at all. You could have the same plane with the same amount of weight, but distribute it differently and get a drastically different and potentially dangerous outcome.
So, like, the same weight in different places can cause totally different problems.
Absolutely, yeah. And it's not just about whether it can fly. Think about the stresses on the aircraft's structure. We're talking metal fatigue, potential for parts to fail, all kinds of bad stuff. Ultimately, getting the weight and balance wrong can lead to a loss of control. And that's the kind of thing that keeps aviation safety professionals up at night.
So where does this whole process even begin? Does it start with the pilot?
Actually, no. It starts way before that, with the aircraft's design. The designers figure out the absolute maximum weight the aircraft can handle. This is based on how much lift the wings generate and how strong the structure is. They also calculate where the ideal center of gravity should be. The point where the plane would balance perfectly if you could hang it from a string.
Okay, so like a seesaw, we want that balance point to be in just the right spot.
Exactly. Then, when the aircraft is built, the manufacturer provides the initial empty weight and the empty weight center of gravity. This is basically the weight of the plane with all its standard equipment, but nothing else. No fuel, no passengers, no cargo.
Got it. So that's like the baseline, the starting point.
Right. Now, as the aircraft is used and maintained, things change. You might install new equipment, make repairs, you name it. And all these changes, even small ones, can impact the weight and balance. And guess who's responsible for keeping track of all those changes?
I'm guessing it's not the flight attendants.
Nope. That would be the FAA certificated mechanics. They have to document every little detail to keep those weight and balance records accurate. It's a pretty big responsibility.
Huge responsibility. So then the mechanic hands those updated records to the pilot, and they're good to go.
Not quite. The pilot in command is the one who has the ultimate responsibility. They have to know the aircraft's limits, the maximum weight, the allowable center of gravity range, all that, before every single flight. And then they use that information to make sure the aircraft is loaded correctly. They're the last line of defense.
Wow, so it's a real team effort. Now, I've heard some of the terms you've used, like CG and EWCG, and I'm assuming there's a whole lot more jargon where that came from.
Oh yeah, there is a whole specialized language around weight and balance. Like for smaller aircraft, a lot of the definitions come from things like Civil Air Regulation 3 or the General Aviation Manufacturers Association Specification Number 1. These documents lay out all the standards. For larger aircraft, there's Advisory Circular 12027.
Sounds pretty technical.
It can be, but the key is that everyone involved, the designers, the manufacturers, the mechanics, and the pilots, they all need to be speaking the same language.
Right. Everyone needs to be on the same page.
Yeah.
So let's dig into the physics of this a little bit. We all kind of know that too much weight is bad for an airplane, but can you break down why weight is such a big deal from a physics perspective?
Okay, so basically weight is a force. It's pulling the aircraft down towards the earth. And to fly, the aircraft has to generate enough lift to overcome that weight. So the heavier the aircraft, the more lift it needs.
Right. So if you add more weight, the wings have to work harder to keep the plane up in the air.
Exactly. And that's where things can get tricky because it's not just about the weight itself. It's also about the forces the aircraft experiences during flight, when it's turning, maneuvering, or even just flying through turbulent air.
So, like, even a small bump can cause a big problem if the plane's too heavy.
Yeah, it's all about the load factor. You see, when an aircraft is just cruising along in straight and level flight, the wings are only supporting its weight. But when the aircraft maneuvers, the forces on the wings increase dramatically.
So, like, more stress on the wings.
Exactly. Like, imagine a 3,000-pound airplane making a turn with a 60-degree bank angle. The force on the wings effectively doubles to 6,000 pounds, and if the aircraft is overloaded, those forces get even bigger, potentially exceeding the structural limits of the aircraft.
Okay, that's a pretty clear example. Now, you also mentioned something called density altitude earlier. I've heard pilots talking about that. How does density altitude factor into all of this?
Density altitude is kind of like the altitude the aircraft feels like it's at. It takes into account the actual altitude, the temperature, and the humidity.
So, like, it can feel like you're higher up than you actually are.
Exactly. And when the density altitude is high, the air is thinner. And thinner air means the wings generate less lift. So the aircraft needs to fly faster to get enough lift for takeoff. And guess what? That means you need a longer runway.
And longer runways aren't always available.
Nope. And that's why pilots need to carefully consider the density altitude when they're calculating their takeoff weight. There are charts in the aircraft's manual that tell them exactly how much weight they can safely take off with based on the density altitude.
So even if you're under the maximum weight for the plane itself, you might still be too heavy for the current conditions.
Exactly. The maximum allowable weight might be different from the maximum operational weight, depending on the environment. Like on a hot day at a high-altitude airport, you might need to reduce the weight even further to take off safely.
Makes sense.
hmm
So we know overloading is bad. But what are the specific things that can go wrong if you exceed the weight limit?
Oh, lots of things. You'll need a longer takeoff run, your climb rate will be slower, you won't be able to climb as high, you'll be slower, you'll burn more fuel, and that's just for starters.
Yikes, that's a whole lot of bad news.
And it can be even worse when it comes to landing. Because when you land, you're putting a lot of stress on the landing gear. And if you're overweight, that stress is amplified. You're more likely to damage the landing gear or even the structure of the aircraft.
And that's not something you want to discover mid-flight.
Definitely not. So we've talked a lot about the overall weight, but what about the distribution of that weight? Why is the center of gravity, the CG, so important?
Yeah, you keep mentioning this CG thing.
It's crucial because it affects the aircraft's stability and control. Think of it like a seesaw. If two people of equal weight sit on opposite ends, it's balanced. But if one person moves closer to the center, the seesaw tips.
And in an airplane, that tipping could be catastrophic.
Exactly. If the CG is too far forward, the aircraft will be nose heavy. And if it's too far aft, it'll be tail heavy. Both situations can make the aircraft difficult or even impossible to control.
So how do pilots control the CG?
By carefully loading the aircraft, they consider the weight of the passengers, the baggage, the cargo, and the fuel, and they distribute it all in a way that keeps the CG within the allowable limits. They use charts and calculations to figure all this out.
So it's like a giant puzzle they have to solve before every flight.
Pretty much.
You
And
know-
for helicopters, it's even more complex because in a helicopter, the CG can actually shift during flight as the fuel burns off. So helicopter pilots have to calculate the CG for takeoff and for landing.
Wow, that adds another layer of complexity. And you mentioned that an aircraft's weight can actually change over time, even if you don't add or remove anything.
Oh yeah, that's right. Over time, things like dirt, dust, moisture, they can all accumulate and add to the aircraft's weight. And those seemingly small additions can add up over time. So aircraft need to be weighed periodically to make sure the records are accurate.
So it's not a set it and forget it kind of thing. And what about when you make changes to the aircraft itself, like adding new equipment or making repairs?
Those changes can definitely affect the weight and balance, and whenever those changes are made, the mechanics have to update the aircraft's records. They actually have to do a specific check called an adverse loading check to make sure the aircraft is still safe to fly after the changes.
Okay, so adverse loading check. That's when they basically try to create the worst case scenario in terms of weight distribution.
Yeah, pretty much. They load the aircraft in a way that puts the CG at its most extreme forward and aft positions, and they do this to make sure the aircraft can still be controlled under those conditions.
That sounds pretty intense.
Yeah.
So let's go back to stability for a minute. You said that the longitudinal balance, the fore and aft balance, is the most important for airplanes. Can you explain why that is?
Well, it's because of how airplanes are designed. You see, the center of gravity is typically located slightly ahead of the center of lift. This creates a natural tendency for the nose to pitch down.
Okay, so like a seesaw that's slightly tilted forward.
Exactly. Now, to counteract that nose-down tendency, the horizontal tail surfaces, the ones at the back of the plane, generate a force that pushes the nose up. And these two forces, the nose-down force from the CG and the nose-up force from the tail, they work together to keep the aircraft stable in flight.
Got it. So it's a balancing act. But what happens if the CG is off? Like, what if it's too far forward or too far back?
Well, if the CG is too far aft, the aircraft becomes unstable. It might be difficult to recover from a stall, which is when the wings lose lift, and it could even enter a dangerous spin.
And a spin is basically what it sounds like, right? The plane starts spinning uncontrollably.
Yeah, pretty much. And some spins can be unrecoverable, meaning the pilot can't get the plane back under control. Now, if the CG is too far forward, you've got a different set of problems. The aircraft will be nose heavy, which means the tail has to work harder to keep the nose up. This can make the plane less efficient, and it can also make it harder to take off and land.
Okay, so too far forward or too far back, both bad. What about lateral balance, the side-to-side balance? Is that as critical?
It is important, but not as critical as longitudinal balance. If the lateral balance is off, one wing might be heavier than the other, which can make the plane harder to control. And you might have to use the aileron trim to compensate, which can increase drag and make the plane less efficient.
So it's like driving a car with a flat tire. You can still drive it, but it's not ideal.
Exactly. Now, there's one more thing I want to mention about lateral balance. It's particularly important for aircraft with swept wings.
Swept wings, those are the ones that angle back, right?
Yep, like on a jetliner. And because of the way swept wings work, if the fuel tanks aren't balanced, it can cause the center of gravity to shift during flight, which can make the plane unstable.
Okay, so fuel balance is super important for those types of planes. We've talked a lot about airplanes and helicopters, but what about other types of aircraft? Like ultralights, powered parachutes, balloons, that kind of thing?
Well, those aircraft typically have different weight and balance considerations. They're often more focused on staying below a maximum weight limit, rather than worrying about the specific location of the CG.
Why is that?
Well, it's because they have different ways of controlling the aircraft. Like weight shift control aircraft, those are the ones where the pilot literally shifts their weight to control the plane.
Oh yeah, I've seen those. It's like they're hanging from a swing.
Right. And then there are powered parachutes, where the pilot controls the aircraft by adjusting the engine power and the shape of the parachute. And balloons, of course, they control their altitude by adjusting the buoyancy of the balloon itself.
So different types of aircraft, different ways of managing weight and balance, but the fundamental principle is the same. You need to stay within the limits to fly safely.
Absolutely. You know, it's easy to take this stuff for granted, especially if you've been flying for a while and haven't had any problems. But the handbook includes some real-life examples of what can happen when you ignore weight and balance.
Yeah, let's talk about those. They're pretty sobering reminders of why this is so important.
One of the examples involves a small plane that was carrying a group of hunters and their dogs, and the dogs weren't secured. So during the takeoff roll, they all shifted to the back of the plane.
Oh no.
Yeah, it's not good. That sudden shift in weight caused the center of gravity to move way too far aft. The plane stalled and crashed, killing everyone on board.
That's a terrible tragedy. And it shows how even something that seems insignificant, like unsecured cargo, can have devastating consequences.
Exactly. Another example involved a plane full of skydivers. They were all sitting in the back of the plane getting ready to jump, but their combined weight was too much, and it caused the CG to shift too far aft during takeoff. The plane stalled and crashed, killing everyone.
So both of those accidents were caused by the CG being too far back. It's a good reminder that these calculations aren't just theoretical, they have real-world consequences.
Absolutely. And the handbook also talks about the hidden dangers of exceeding weight limits. Even if you manage to take off safely, landing an overweight aircraft is way more risky. You're putting a huge amount of stress on the landing gear, and you're more likely to have a hard landing, which can damage the plane.
And even if the plane doesn't break on impact, you could have hidden damage that could cause problems later on.
Exactly. It's like bending a paperclip back and forth. It might not break the first time, but eventually it's going to weaken and snap.
So it's all about minimizing those stresses to keep the plane safe and in good condition. It really is amazing how much goes into making sure an aircraft is safe to fly.
It is. It's a testament to the skill and dedication of the engineers, the mechanics, and the pilots. And it's a reminder that we should never take aviation safety for granted.
So the big takeaway here is that weight and balance is not just some boring technical detail.
Nope.
It's fundamental to aviation safety. It affects everything from the aircraft's performance to its stability to its structural integrity.
And it's something that everyone involved in aviation needs to understand and respect.
You know, it's interesting to think about how these same principles apply to so many other things in life.
Yeah, you see it everywhere, like loading a cargo ship, designing a skyscraper, even just packing a suitcase.
It's all about balance.
Exactly. And it's about understanding how weight affects stability and performance.
So here's something to think about. If we put so much effort into making sure airplanes are balanced, what other things in our lives might we be overlooking? What seemingly mundane things actually have really important underlying principles that we should be paying more attention to?
That's a great question. It definitely makes you stop and think about the things we often take for granted.
Absolutely. So next time you're packing your car for a road trip or stacking dishes in the dishwasher, maybe take a moment to consider the weight and balance. You won't be surprised at how much of a difference it makes.
You never know, it could save you a lot of trouble in the long run.
Thanks for listening, everyone. We'll see you next time for another deep dive into the world of aviation.
See you then.